Hello guys, and welcome back to my channel, and I've got a new tutorial for you. In this tutorial we're going to program this 3D model. I want to use this time all the toolpaths available in Mastercam. I mean, we're not going to use each one of them, but definitely we are going to use the full range of toolpaths available in Mastercam. So we're going to use 2D, 3D and multi-axis. So we're going to create some planes and we will find out how we can create those planes easy and why and where we need to create those planes. And also we will do some simultaneous operations as well. For programming this part, I will need to use this tall vise, and the reason is because we're going to work on the part when our table is in vertical position. So we're going to use a axis of 90 degree, and sometimes we will have to go over and use the machine limits up to 20, even 30 degree over the 90 degree. This is why it is important to use the tool vise, and this way the tool and the holder and the part of the column of the z-axis is being kept away from the table so we can avoid damages and collisions. Okay, so this is how this part look like, and this is the WNT vise, and this is really good. I really like this vise, we use it all the time. Okay, so let's go back to toolpaths, and this is our stock. So our stock is 108 by 216 by 200 mil high. Okay, and the stock origin is 000. Okay, so now we can start programming. And first I want to rough this part out, and I'm going to use multi-axis pocket into this because it's easy to and simple to set it up. So first let's select our tool. So I'm going to use 20 mil bull nose cutter with 2 mil radius. And of course, for these operations, we need to assign the stock. So I'm going to use a job setup stock that we just went through. And in the cut pattern page, this is going to be my machining geometry. So we're going to select the whole 3D model. You can triple click on that or press Ctrl A and it will select the whole model. Stock to leave, it is how much material we want to leave for finishing. And I will leave 0.3 millimeter. So now, because we are doing roughing, I want to show Mastercam the shape of the floor, which is going to be taken as our pattern for machining, because we're going to do roughing and the strategy is offset from floor. So Mastercam will look at that surface that we selected, and the tool will be always normal to that floor. I'm going to use the type as dynamic, and I'm going to use zigzag because we'll be plunging inside here, inside a little bit here. So I'm going to leave as zigzag. And for my conventional feed rate, so the motion back, I'm going to use 2000. Okay, and I want to machine it by regions. So let's go and set up our depth step. So my tool is, how much fluid do we have? 75 mil fluid. So let's go back to cut pattern, and I'm going to set it up to 50 millimeters. And because we are taking such a big cut, I'm going to change the maximum step over to 2 mil. Let's set up to 3 mil. It will be easier to see the toolpath. Cut tolerance, you don't need a high cut tolerance because we have 0.3 left everywhere. So I'm going to change that to 50 microns. Okay, let's move on. Press on that small plus next to cut pattern, and we're going to set some depth steps. And I'm going to add some intermediate slices, which are just additional cuts that we will add between those main cuts. And those cuts will be only close to the walls of my 3D model, so we won't be roughing the whole surface. So I'm going to set my constant depth step to 10 mil, and I want those cuts between the main cuts to be machined after the last depth step. So first we will rough everything 50 mil down in 50 mil depths, and then going back in 10 mil increments, and we'll be taking the material closer to the shape of the part. So I don't want to have like 50 mil steps here. That's why we are adding them on. In the tool axis control, we do not have anything here because it's a roughing. So all the cuts, the tool axis control is being based on the pattern you select here. So in our case, strategy is offset from floor, and our floor is this. So all our cuts will be horizontal, like the shape of the floor. Okay, so let's move to collision control, and we're going to do collision avoidance by checking against machine geometries. And I'm going to leave unchecked against in process stock because I wanted to show you how it works. So in the linking parameters, I'm going to leave these settings as default. And if we have any trouble with any of the linkings, we can always come back and reset. On the roughing page, I'm going to change the ramp type to a line, which is going to be just simple plunge, as we are doing only plastic material. We don't have anything to change on the utility. We don't. Let's go back quickly and make sure that our planes are on top. So I'm going to use quickly those arrows to copy top plane to tool plane and construction plane. And let's have a look what we can get from those settings. And this is our toolpath. Okay. So the reason I've done it this way, because I want to leave this internal section here solid. So it will support the whole 3D model, the whole part, while I'll be finishing all the external features. So let's have a look how this is getting done. So let's go to machine simulation settings. I'm going to select my Vari-axis machine. Fixture, I want to go from level, and my level with vice is 1001. And the stock, I'm going to use Mastercam stock definition. Rest of the settings I'm going to leave as it is. So let's go and simulate it. Okay, so this is our machine, and I don't need to see the body of the machine or the housing. So I'm going to switch that off. And this is the part I want to see. Okay. So now let's go and play it. Okay, and this is what I wanted to show you. Remember when we were setting up this operation, in the parameters, collision control page, we didn't put the tick against check against in process stock. And in the result, you will see that we will have some collisions. That every time the holder turns red, it means that it's a collision. So Mastercam at the moment is aware of the 3D model. With the current settings, Mastercam knows where are different faces of the 3D model, and it will avoid with the current settings all the walls, and it will not collide with the part. But because we didn't ask Mastercam to check against in process stock, Mastercam will ignore the material that is left from the roughing. And in the result, as you see on the screen, we can have some collisions between the holder and the material that is left on the 3D model after roughing. So let's go back quickly to the parameters of this operation and we will fix it. And in the collision control, I want to leave that tick as well. Okay, so we quickly jump to the simulator to confirm that our problem is sorted. So let's run it quickly. And this is where we started to have some collisions before we change the settings. So now, as you see, Mastercam is aware of the stock that we are leaving during this roughing steps. And we don't have any collisions anymore. Okay, so if you have any problems with holders plunging into material or cutters plunging into material that is left over, check the box in the collision avoidance to check against in process stock, and that will sort the problem. Okay, so let's move on, and now we're going to program the pocket on the top face of this 3D model. So for this I'm going to use 3D pocket, and as my machine geometries I'm going to triple click left mouse button on the 3D model to select the whole 3D model, and to limit the working area or my machining area I'm going to use a containment boundary. So I want to make sure that I'm on the solid mode selection, and with the closed loop on, I'm going to select the internal edge of the face. So I'm going to limit this internal pocket. Okay, select OK, and now let's set up our cutter. So I'm going to use flat end mill 12mm diameter. And before we start setting up our feeding speeds, I'm going to turn on the coolant. And this way we will wash away the cuttings from inside the pocket. And also because we are cutting glass filled peak, it is good to turn on the coolant. So let's reset quickly our feeding speeds. I'm going to keep feed rate and plunge rate at the same rate. And this will help me to change it on the machine if I need to adjust my feed, because we will get only one feed rate in this operation. My spindle speed is going to be 6,500 rev per minute. And now let's go to surface parameters. Oh, before we go, let's check our planes. We need to make sure that our tool plane and construction plane is on top, because we are approaching the part from the top. And the cutting tool is always normal to the tool plane in 2D and 3D toolpaths. Okay, so let's move to next tab, and it is surface parameters. And I'm going to leave stock on 0 because I want to finish this pocket with this one toolpath. My clearance is going to be 5 on absolute, and my datum is on the top of the part. Actually, let me quickly show you where is our Z0 on this 3D model. If you want to see WCS arrows on your screen, just simply click Alt F9 on your keyboard. So as you see, our datum is on the top face of 3D model. I don't need any retraction. Feed plane I'm going to leave as 5mm, and let's move to rough parameters. So first let's set up our maximum step down. What is my cutting length? It's 19. So I'm going to set it up to roughly 30%, which is about 6mm. And because I don't want to cut this 3D model all the way down to the bottom face, because I selected the whole 3D model, I'm going to limit my cut depths. And I'm going to use absolute, and my first cut is going to be on -4. And for my maximum depth, I'm going to use right mouse button menu and select Z from the screen. So first I'm going to pick the deepest point of this pocket, which is this edge, and I'm going to cut this a mil deeper. So let's go for -64. So I'm going to cut from 4 to -64 in 6mm depths. So let's move on now to pocket parameters, and we're going to select the cutting method. And I'm going to use a high speed, but my step over, I'm going to change it. I don't want my cut to do 9mm step over distance. I'm going to use something rather smaller. And I'm going to use a 20% of the cutter diameter. That should be good. It's still going to be only like 2-3 passes maybe, nothing much. I'm going to set 0.25 for my finishing cut, and let's go and see our toolpath. And this time I'm going to run just the backplot to see how the toolpath looks like. It looks like I could go a bit bigger step downs, but I'm happy with this, so I'm going to leave that. Let's have a look at this 3D model. What can we do next? So we've got this flat face here. We've got the flat face here, and also we have some big, large flat faces around the part here. So what I was thinking is maybe instead of generating these features with ball nose, I would maybe use face mill and face each face as a separate toolpath, and then do the same with the bottom. Yeah. Okay, so let's start with this face. So if you look at the 3D model, when you use 2D toolpath or 3D toolpath, you have to tell Mastercam what plane you want to work on. So what side the tool will be approaching to the face. So this is my top, and this is my front face. Okay, so this is the front of the 3D model. So when I'm machining this face using the face mill or this face, I want to set my tool plane to front. And this is on the right hand side is a plane right, on the left is left, and the back is back, and in the bottom is bottom. So let's start with front. And for that, I'm going to use a contour. And as my chain, I'm going to select this one edge and I'm going to extend it. Okay. As a tool, I'm going to select 80 mil face mill. I'm going to use 2000 feet and 3100 spindle. Okay. So in cut parameters, I want to have a compensation on the control, so I can adjust my position. And of course, we are on 2D and compensation left. So all these settings are okay. We'll have a look into this in a minute. So depth cuts, I want to have one roughing depth cut and one finishing. So one roughing cut, one finishing. So I'm going to set this for really big value. I'm not sure how much material is there, but I just want to have one roughing, one finishing, and the finishing cut I want to be only 0.5 mil. Lead in, lead out, 60% and 60% are my standard settings, so I'm going to leave that. But I want to adjust contour, and I'm going to adjust maybe add on maybe extra 20 millimeters, and I'm going to copy that over to the exit. So the front we start earlier and finish later, so longer. So we extend in the front and in the back. Sorry. Multi-passes. Yes, I want to use 30 mil step over, and I want my finish passes to be with all the depths. Okay. Link in. My depth, I'm going to switch all these to incremental. So my depth I'm working on is that. But at the moment, if I select it, it will be wrong because we are still on the tool plane top. So I just wanted to show you. So it says it's 0, okay? But if I select on the same face somewhere here, it will show me different value. So what we have to do is tell Mastercam what our tool plane is. And as I said, we are working at the moment on the front. So this is our front of this 3D model. That's top, this is front. So let's change that to front, and I'm going to copy this to my construction plane. So now if we go back to Lincoln, you'll see that you'll be able to select it properly. So it doesn't matter if you select this point, it will be 0 incremental. Incremental is from the edge that you selected, or even this one, it will be still 0, and even the same point that showed different way, it will still 0. So my top of stock is 5. Let's say my feed rate is going to be 10. And let's have a look. So we should have 2 cuts here and 2 cuts here, which is okay, but we still have something missed here. Okay, so let's switch to front tool plane and construction plane, and I'm going to measure that. I'm going to measure that distance between this edge and this edge, and it is 1.82 millimeters. Okay, escape, 1.82. So what I'm going to do is, in the cut parameters, I'm going to shift my tool minus 1.8 against the edge, or even 7.5. Okay, in relation to the edge that we selected. So look at that. Nice. Now it goes through this whole flat area. So what next? Next is going to be, I want to go side by side, so I could basically maybe even hit that straight away. So I'm going to copy that. All the settings are okay. Copy after, and I'm going to just change the geometry on this one. Rechain all, and let's go by that. Okay, that's fine. Okay, so we have 2 passes here, 2 passes here. Okay, so what I'm gonna do now is copy this one, copy after, and I'm going to change my tool plane. That is going to be 0, okay? And then my tool plane, I'm going to change to right hand side. And this is because we are going to work now on the right hand side. So what chain we want to follow this time? So my chain is going to be this edge, okay? And this is because I want my tool to be on the left hand side and pass from here going in that direction of the red arrow. Okay, and I cannot select this edge because we have fillet already here, so I don't want to machine it. I don't want to touch it. Okay, so let's select OK, and what else we need to do is change our linking, the depth. Okay, so my depth, we are working on facing the part on this depth, which is correct. I don't need to change it because we were on incremental. So that's okay. So now we have front, right. So now we need to do back. So I'm going to copy this one again below. After that, copy after, and this is because we've got already this minus value here. Oh no, sorry, I copied the wrong one. Of course I did. So I want this one. Copy. Okay. So I'm going to use it next, but this one I want to use for the back because we've got this value here. So we don't need to change anything here because our depth will be on 0 distance from incrementally from the chain that we select, but plane is going to be now back. Okay. So what we need to do now is to change the chain. Okay. So this is our front. So we need to now go to this one. geometry and rechain all, right click, rechain all, and just this one bit here. And now this all should be good. Okay, so the next one is going to be the left hand side. So I'll go first and pre-select the chain, and I want to be, this is our left. So if we go and select left, this is our left plane. So let's go here, 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 and here. And this is what I need. Okay, so now in parameters, I just need to change that to the left. And this is it, because I've got that already on 0. Okay, so look at this. We can now go and, oh, sorry. Because we are on this, we were on the front here, on this chain. So what I wanted to do is, on this side, I want to copy that, copy after, and I'm going to change that to here. Okay. So what I just did is copy this one and paste it underneath, and just simply added this edge because it's on the same tool plane. Okay, so let's quickly jump into simulator, and this time we're going to do verify. Let's see if we need to adjust anything. Nothing, and finishing passes. I could probably take it without multi-passes. Okay, so I can tell that this face with the first cut doesn't do much. And let's go back to our toolpaths and I'll show you what I mean. Okay, so we've got those all sides machined. So let's have a look at something else. So let's say this left hand side. So this is our front, and that tool plane is on the left. So this is the left hand side. Let's just double check something, because the first cut, it doesn't do really much. So we can actually, what we can do is go back to parameters, and I'm going to switch off multi-passes. And I'm going to do it for all of them. The one thing I'm going to change also is lead in, lead out, and I'm going to change that to tangent. So it'll come from here and then blend in. And I'm going to change that to all of them. So I'm going to pause the video for a second. And the last one, switch off multi-passes and lead in. Instead of having this entry, I'm going to change that to tangent. So let's go, it will go from here, okay, tangentially. I'm going to copy that to the exit, and this is what I wanted to do. So now it will cover the whole part. That's fine. Okay. I'm going to quickly jump to toolpaths, stock, and I'm going to create a stock model. So now our initial stock is going to be stock setup, this stock here. And source operations, I'm going to calculate my 3D model based on all of them. And I want to have more accurate stock model. So I'm going to tie up those a little bit. And in stock definition, I'm going to change the material to glass so I can see through it, whereas how much stock I have on my 3D model. So let's change the color, maybe to something like this. Okay. And let's have a look. Okay, so at the moment you can't see really through the 3D model, through the stock. So to be able to see through stock, you have to activate material rendering, and you can go to View tab and hit this button here. And now you can see how much stock is left on the machined part. Okay, so with our next toolpath, we are going to machine those cutouts. And the way I'm thinking, we're going to machine these two first, and then through those cutouts, we're going to machine those fillets inside. Okay, and then we will do the same here. We're going to machine those at the end and machine those bits inside. So yeah, let's start. So for that, I'm going to use Multi-Axis Toolpath, and we're going to set our 3+2 roughing. Okay. As a tool, I'm going to select 8mm flat end mill. Feed rate, I'm going to change that to 1000, and for our material, 5,500 spindle speed. Stock, I'm going to activate stock, and I want to use my stock model we just created. So Mastercam will know exactly where our stock is. In the machine geometry, I'm going to add everything, so a whole 3D model. So now let's move to cut pattern page. And here I'm going to use an offset style and maybe in 2 slices. That'll be fine. I'm going to add the containment boundary. And I'll just add quickly this. Okay, so this is my containment boundary. Select OK. And I'm going to go one way, climb, machine by levels, and my step over, I don't want to go too hard, so I'm going to use 3mm. Let's quickly move back to model geometry page. I want to make sure that I left 0 for stock on walls and floor. Yeah, that's correct. I don't want to leave stock. I want to finish this pocket in this operation. Okay, so let's move to advanced options for surface quality. And we don't need to change anything here. Maybe if I'll get any problems with the finish, then I will come back later and activate arc fit. In the containment settings, I want the offset to be inside. I don't want my cutter to move outside the boundary that we selected for our containment. This way Mastercam will produce cuts only in that containment area that we selected. Let's move on to next page, depth step, and we do not need to add any depths. It is just a thin area that we're going to machine through. I'm going to leave these settings as default at the moment, and let's move to tool axis control. I don't want to use automatic mode. I just want to machine the 3D model from 2 sides, and I want to specify what tool plane to use. So let's go to manual. And here I'm going to add another line because I want to use 2 different tool axes or 2 different tool planes. Okay, so first I'm going to select side, and Mastercam will select for us right side, and then I'm going to select different tool plane for the second line, And this time I'm going to use named plane. And I'm going to use opposite side, which is left hand side. And just to make sure that we have properly selected the tool planes, I want the X value to have different value. So one is with the negative sign. Okay, so let's go to collision control. I'm going to check against machine geometries and check against in process stock. Let's move now to linking page. And first I'm going to set a height for my clearance. And I'll go for something small, 20, let's say, for the start. And direction is machine direction. And the type, we have only one option here, which is plane. If I have any trouble with those settings, I will come back later and adjust my height or links. So before I finish, let's go and check our planes. For my multi-axis, I usually set work coordinate and tool planes and construction planes to top. Okay, and this is our toolpath. So as you see, we're going from one side, then retract around, and we machine the second side. So with our next operation, I'm going to finish those internal fillets on both cutouts that we just made. And I'm going to start with this side here. Look at my origin. And for that, I'm going to use a Morph from Multi-Axis Toolpath. So let's navigate to Multi-Axis Gallery, select Morph. And I'm going to use former ball nose end mill. I'm happy with those settings. Stock. I don't need a stock for this operation. And in the cut pattern page, as my pattern from, I'm going to select a curve. And with this button, I'm going to select the upper edge of this fillet. So we go around. Okay. That's my pattern from. So let's go in on the top. Okay. And now pattern 2 is going to be bottom edge of that fillet. Okay. And of course, my machine geometries, the drive surfaces, are going to be all the faces that make up this fillet. I don't want that. Oh no. Okay. Let's do it again. Okay. So I've got only this fillet around. I'm not going to leave any stock here, so that's on 0. I'm going to use one-way machining and machine by lanes. My step over, I'm going to leave it at the moment as, let's say, 1 mil, just to see if it's generating the right thing. Advanced options for clamp and conventional, I'm going to leave that as it is. And advanced options for surface quality, I'm going to leave approximate. That's fine. Tool axis control. And how are we going to control our tool axis? So basically, I want to go from this side. So actually from the X direction. So let's select fixed angle to a axis. And as I mentioned, our axis that we're going to fix our tool around this X axis. So I'm going to select X. That's fine. And I'm going to activate smoothing, but we do not have much variations on that. So I'm going to do smoothing. That's that. And in the collision control, I'm going to leave that as it is here. but I'm going to add another level, and I want to tilt the tool only to avoid geometries that I'm going to select on the top here. So I'm just going to simply drag a window like that, just to select everything on the top here. Okay. So in advanced options, I want to make sure that my rotary axis is in Z, because our rotary axis is on the Z axis. And I'm going to leave as equal tilting. We don't need anything here, nothing here, linking. Yeah, so I'm going to change that to cylinder. I'm going to change that to 100 mm. On the Z axis, that's fine. And I'm going to leave rest of the settings as default. Roughing, I will switch it off. Utility tab. We're going to come back here and set this, but let's first have a look what we can get and if the tool motion is correct. Okay. Okay. That looks okay. So now let's go back. And I'm going to add transform, and I want to rotate this toolpath around the Z axis. Okay, so we're going to rotate it around Z axis 180 degree. So basically around the Z axis. So we're gonna get this side. And how many places we machine? 2. And the rotation angle is 180. Also in the cut pattern page, I'm going to change that to 0.15 step over. And we've got our toolpath. We can go quickly to machine simulation. First, I'm going to hit the save button. What I'm going to do is simulate these two operations. Okay. This is how it looked, how that would look inside the machine. Okay, so now when we have those big cutouts finished, we can move on and do the smaller ones. So we are going to use the same method. So let's go to Toolpath, Multi-Axis Galleries. We're going to use 3+2 automatic roughing again. For this, I'm going to use flat end mill 8 mm, and my cutting speeds are 1,000, 1,000, and 6.5. Okay. Holder stock. I'm going to select the stock model, number 1, the one we created here. And the cut pattern, I'm going to use offset, and I'm going to leave slices as 2, and also I'm going to change my maximum step over to 2, and I still want containment boundary, but I'm going to select now this edge here. 1, 2, 4, okay. So these settings are okay. Maybe actually slices, I'm going to use 3. And tool axis, I'm going to use 2, but I'm going to select tool plane, and from my named planes, I'm going to select front. And for this one, named planes, and I'm going to use back. So it's a front and back. So this is front, and this is back, what we're going to machine. So these took out. Okay. Let's see here. I'm going to fit arcs. I'm going to leave these as it is. Containment, I want to be inside. Depth step, I'm going to leave everything as it is here. Heights, and at the moment my heights are being calculated from stock and machine geometries. Okay, and our machine geometries, we are going to select the whole 3D model. So now my depths are being calculated from based on the whole 3D model plus the stock. So I'm going to leave it as it is, but then we come back and we will do adjustment in here. Okay. Collision control, I'm going to untick those. I don't need this at the moment. And maybe I'm going to change that to, let's say, 100 mil. Okay. Roughing, I'm going to do plunge 90 degree into the material, and let's have a look. Yep. Okay, so we've got our toolpath. And this is not too bad. Okay. Okay, but let's go back and we can limit our depths a little bit so we don't go as deep. So if we go to heights, we can set limit height, user defined, and let's maybe do, I'm guessing 35. Okay, so we've got our toolpath, and yes, that actually looks all right. Maybe we could go a bit deeper, but this looks okay. So I'm going to leave it as it is. Another one thing we can quickly set up now is we need to go through this small cutout here and machine those internal fillets. And for that, let's use unified toolpath. So this is our front. Okay. So let's go to Multi-Axis Gallery. We're going to select Unified, and we're going to use one of those automatic features of on the Unified. So I'm going to use 8mm ball nose cutter, 2000 feed rate. Whoa. 2000, 9.5. Okay. Okay. I don't need any stock, so I'm not going to use stock. And as I mentioned, I'm going to use this automatic row. So Mastercam will generate the toolpath based on the machine geometries, and my machine geometries are going to be those internal fillets here. Okay. That's okay. So I'm going to change my method now to spiral, and this way we will have one nice continuous motion through all the faces of this fillet. My step over, this is all good. I'm not going to change anything else here. So at the moment the method is machine boundary parallel. I would like to go more from top to the bottom. So I'm going to change that to Morph. I'm not going to leave any stock here. We are machine entire machine area. Let's move on. That is okay. I want to perform full spiral, and first and last contour we're going to do full contour. Okay, we're going to close it. In the advanced option for surface quality, we can ask Mastercam to divide every pass into small distances, and you can set maximum distance. Also, you can set minimum distance. But to achieve better finish, of course, we need to remember about step over. So if we go with the smaller step downs, step over distance, we'll get better finish. But also surface quality cut tolerance is important, because it is how precise, how far away from your surface each point is going to be distributed. So each pass, how close to the shape it is going to be. We are not going to change anything here. Containment, we don't have any containment. Machine geometries, we're going to leave this as default. And we are going to do some changes in tool axis control. For our 5-axis output, my tool axis control is going to be from point. And now I'm going to select a point. To do that, select this arrow button here. And then I'm going to find the midpoint. To do that, the easiest way is to leave the cursor on the intersection here of the two edges, and it will leave a green mark. And do the same thing on the other side, and Mastercam will generate the red point that is midpoint between these two green points. Simply select that, and this is our point for controlling the tool axis. Collision control, we're going to come back here, but we will change that to tilt tool as on the other one. We're going to change that to cylinder 100mm radius. Also, we will have to adjust some utility settings, but we'll come back after I adjust this point position. So I'll do the rest of the adjustments after my point is in the final position. So to do that, I'm going to select this point and then select dynamic. I'm going to place the genome on that point. I mean those XYZ arrows, and using the Y arrow, I'm going to move the point away from the surface, maybe let's say 50mm. And if you control your tool axis from point, the as a simple rule, the farther you are away from the machining surface with this point, the smaller angular changes you will get. The easiest way is to show you, to explain how this tool axis control from point works. So I created the point I'm going to use as tool axis control, and one point is 20 mil away from the surface, from the machine surface. Let's say we want to machine this surface across. And then another point is 70 mil, and then the third point is 200. So now if I go and grab this point here with my middle button, just press down the wheel and hold that. So now to get from one surface side to the second one, you see, just aim this point to the edge. This is how big motion I have to do with every pass. Okay, and the angular change is going to be about 141 degrees. So if I grab this point that is 70 mil away from the surface, the motion is going to be a lot smaller. So the angular changes is going to be from this to this. So it's not that drastic change anymore. But if I grab this one, that is 200 mil away, the changes are not big at all. It's just a small move, small motion, small tilt action. Okay, so generally if you want to use tool axis control from point, if you don't have to be close to the surface, go as far as possible. Okay, if you can. Sometimes we have to be close to the surface. So just bear in mind, generally the farther away from the surface you are when you are controlling the tool axis from point, the less angular action you get. And the finish on your part will look much better. So now if I grab this point with my third mouse button, I can use this point to aim around, track it around the machining surfaces to get a feeling how much motion, how much rotary and tilt action I'll get during machining. And I'm a bit too high, so I'm going to move that as well, maybe 10 mil. So we move this point 50 mil away from the surface and then 10 mil down. Okay, and that looks okay for me. So I'm going to click OK. So I've got move, OK, and it will automatically update that. So if you regen the toolpath, you'll see the result. Okay. So let's go back. And what I'm going to do is add the collision control, and I'm going to change that to avoid collision by tilting the tool. Okay, I'm going to add the whole cutter, and as avoidance geometry, I'm going to select just this whole top thing. Okay, just drag a window to have that section here of the 3D model selected. You can select the whole 3D model if you want. So let's go back. Okay, so this is our toolpath, and now you can see that we enter through the top cutout and we safely machine the whole fillet inside. So let's go back to parameters, and now we're going to set our utility. Let's go and add some transform. Okay, so in the utility tab, we go to transform, and we'll be transforming this toolpath around the Z axis. Okay, so we'll rotate it 180 degrees around the Z axis. So how many places we machine? 2. Okay, we machine two features. Okay, so we want to transform it twice. You want to have one here and one here, and they are 180 degree apart. Okay, so as I said, we move it from here 180 degree to here around the Z axis. And let's have a look. Okay, it looks okay, but we of course we have to simulate it to be able to see. I'm going to move that to different level. And I already prepared the tool axis control for internal fillets level, and I'm going to move it to that level here. Okay. Okay. So now we're going to set up quickly another one quick operation. What I'm going to do quickly is we can use a female radius cutter and go around and finish a little bit in here, but we can do it quickly using the same toolpath. And how we're going to do it is copy and paste after. Okay, and now quickly we go to parameters, and we're going to change only one thing. In a cut pattern, we're going to remove that and select and select all this. Oh, what happened? Okay, let's click OK. And this is what we have. Okay, let's see how that all looks in the simulation. Okay, so this is our simulator. Mazak variaxis. I use it at work. And okay, let's just switch off the housing visibility. I just want to see how it's getting machined. First, second side, we rough it, finish the fillets. And this is what we just programmed as well. So by using collision control, we avoid hitting those sides here, plus we control the tool from point. And that is giving us quite smooth motion. There's no joggy movement, it's all smooth. So yeah, that looks good. And this is what we do for outside. It's also not moving too much, which is good. Looks okay. So we have basically the top finished, except this fillet and those fillets here, okay? Okay guys, thank you all for watching, and I'm going to upload the 3D model in a few days for you to start training. And if you like my channel and my videos, my tutorials, subscribe for future content and hit the like button. The next part of the tutorial will be ready in roughly a week, maybe 10 days, depending on my free time. Take care.